Hello 6th grade, and welcome to the second video in the Mixtures and Solutions series. This video is to help you understand the differences between mixtures and solutions, and it's a video that you should be watching after you have already finished the investigation where you investigate the properties of powder, salt, and gravel, and you attempt to separate each of those from a mixture of those substances with water. This video is created by Before Sciology. Well, I don't know if that's their actual name, but someone who calls himself Before Sciology who put this on YouTube, so I give them all the credit for creating the graphics, but I will be doing the talking so that I can explain all of this in a way that you can understand and relate it to what you've already learned. Here we go. So Before Sciology presents us with the question of mixtures and solutions, and first asks us to consider examples of mixtures, or what a mixture is. So you can write this down. Pause the video. What is a mixture? A mixture is two or more substances that are added together, and each substance still retains its own properties. So we've learned about properties, and in a mixture all the parts of the mixture retain their own properties, such as if you were to mix nuts with M&Ms, and if you were to mix peas and carrots, you could pull the peas and carrots out and separate them very easily, and they each retain their own properties. So what is a solution? First of all, a solution can exist in any state, solid, liquid, or gas. Brass is an example of a solid solution. It's an alloy, or a homogeneous mixture of copper and zinc. The trumpet may be made of brass. Liquid, sugar water is an example of a liquid solution, and it's a homogeneous mixture of sugar and water. And air is an example of a gaseous solution, or a gas solution, and it's a homogeneous solution of nitrogen, oxygen, and carbon dioxide. You can't separate those. When you breathe in the air, you breathe in all of them together. Comparing a mixture and a solution. So if you were to make a mixture with sand and water, you could see the sand in the water, and you could also separate the sand from the water by filtering it with a screen or with filter paper, such as you've done with powder and gravel. As far as a solution goes, it might be a little more difficult for you to separate the pieces of a solution, or the elements of a solution. The sugar, in this case, if you add sugar to water, is known as the solute, and the water is known as the solvent. That's what you dissolve something into. The sugar particles are evenly distributed in the water, just like salt particles are evenly distributed in the water, and they seem to disappear, but they are still there. And you could separate them through evaporating the water, and what you would have left is whatever the solute is at the bottom of the cup. So, some examples of solutions are flavored drinks such as Kool-Aid. Chocolate milk is another example of a solution, because if you make chocolate milk by adding powder to milk, the powder is evenly distributed, and all the particles are distributed in such a way so that they cannot be seen, and it looks like one element. Cement is also an example. So think about the reasons why these three things, flavored drinks, chocolate milk, and cement, are a special type of mixture known as solutions. And you can ask yourself this question: why are these things solutions? And be prepared to talk to me, or to write about what the differences are between mixtures and solutions, and also to give some examples of mixtures and solutions, which again are a special type of mixture where all of the particles are evenly distributed in such a way that they seem to disappear. Now, I'd like to give you the opportunity to practice sorting mixtures and solutions by going to the fossweb.com website and typing in modules 3-6, and if you take a minute, pause the video and write that down. You can type it into the URL, and if you do that, it'll take you to the Mixtures and Solutions website. And at the Mixtures and Solutions website, you can choose to click on Mixtures and Solutions and Junkyard Analysis under Activities. So if you click on Junkyard Analysis, it'll take you to this game where you can sort different things in this junkyard by clicking on them, and don't try to move them anywhere because that doesn't work. Just click on them and the analyzer will let you know what's in these materials, and then you can predict whether you think they're going to form a solution or a mixture when mixed with water. And sand, I'll predict, is similar to diatomaceous earth or powder, so I'll predict it's going to form a mixture, and then it asks you to dunk it, and it tells you whether yes, it forms a mixture or it forms a solution. If I click on calcium chloride, I find out that it's 64% chloride and 36% calcium. I'm going to predict that it forms a solution and then dunk it and find out whether I'm correct or not. Practice with these 14 items that you find in the junkyard. You can do it more than once if you would like, and then be prepared to tell me the differences between mixtures and the special type of mixture that is known as a solution, and give me some examples before you can move on to the next investigation about chemical reactions. Good luck.